thank you all for coming. There'll just be a few of us here today then. Metaphysics of the Laws of Nature, number 4. No need to introduce myself again. So just to review where we've been, first lecture we talked about the laws of nature concept historically, and we saw a few different examples of views about the laws of nature. We started with Aristotle in a sort of pre-law thinking. The law of nature concept really comes from Descartes. Then last time we saw what would happen if we try to go back to Aristotle, if we should keep the laws or not. Now we're going to move over here to a Humean regularity view. It's still a bottom-up view. We're not saying there's top-down governing laws going on, but we sort of also don't believe there are causal powers in the world. So it's neither the laws nor the causal powers which are making things the way they are. We sort of just accept them as a brute fact. But I'll get more into that now. And Humeanism has developed into quite substantial view, coming from David Lewis and some of his successors, which we'll be spending most of our time talking about today. So in the previous lecture, I noted that people are often led to at least talk about dispositions and causal powers. That's definitely part of our everyday language, and it's an important part. Causal talk is required for causal explanations, in the same way that you need moral terms to talk about moral subject matter. But this doesn't necessarily imply that there's causal powers fundamentally at the bedrock of the world. And physicists often talk about how fundamental particles affect each other. And in fact, given their sort of methodology for investigating things, this is all they can do. You sort of turn on the experiment, you send in the electrons, you notice how they affect other things, and you get this sort of dispositional, circumstantial behavior of the particles. And that's built into how physicists talk about these things. But that's all just talk. We have what we talk about, and then on the other hand, we have what we see. So we only ever see constant conjunctions of categorical or non-modal properties. This is something that Hume put us onto. We see the shapes, sizes, motions, and arrangements of parts. I'll get onto what constitutes a categorical property a bit later in the talk, but we only see these sort of non-modal. We never see the magic of causation or necessitation, right? We love to talk about it, but we never see it. So that's a bit of a strange thing. And according to Hume, all of our ideas come from experience, from what we see and interact with. So we should work with this non-modal properties to sort of ground what we're doing when we talk about causation. To ground what we talk about in what we see, roughly. So the idea, therefore, of necessity, says Hume, and causation arises entirely from the uniformity observable in the operations of nature, where similar objects are constantly conjoined together, and the mind is determined by custom to infer from the one the appearance of the other. The two circumstances form the whole of that necessity which we ascribe to matter. Beyond the constant conjunction of similar objects and the consequent inference from one to the other, we have no notion of any necessity or connection. So as I said, we're trying to take what we see of causation, which is constant conjunction, and base how we talk about causation on that. We're going to say that causation is merely a custom that we have for linking observed causes with their observed effects. This is a metaphysical reading of Hume, by the way. There's two ways of reading Hume. There's a metaphysical reading and an epistemic reading. I'll talk about both of them, but let's hit the heavier metaphysical one first. So cause and effect is merely a custom we have. There's no cause-effect relationships out there in the world until we have our custom to associate them in that way. There's no causation really out there in the world. The cause and effect pairs that Hume has in mind, say all F's or G's, they have to have a few properties. They have to be in constant conjunction. And this really has to be exceptionless for his program to work out. So whenever we see an F, we always have to see a G follow after. We see two billiard balls coming in to collide, and then we see them moving apart. Right? We see somebody strike a match, and then we see a flame. So we have these constant conjunctions. If the cause and effect pairs that you're thinking of admit exceptions, so if you try and strike a match and the flame doesn't come out, and you say, oh, it was because the match was wet. You can't strike a wet match and make it flame. Well, it's not really the cause and effect pair of the match causing the fire, it's a dry match causing the fire. So you have to continue to qualify and build in an understanding of what the real exceptionless cause and effect pairs are. And it's not really a cause-effect relationship unless you fully specify what in the cause is necessarily conjoined with what's in the effect. Okay. But Hume also has a sort of psychological component he builds into it. The mind has to be compelled to move from the idea of the cause to the idea of the effect. So it's not just that there's a constant conjunction out there in the world. It has to be one which is somehow psychologically compelling for us, humans. And people debate how much Hume's philosophy relies on this part. I'm going to just note it as an important part nonetheless. So no random coincidences will count as cause and effect relationships. If it just so happens to be there's a sort of accidental regularity, every time the clock has its second hand at a prime number, some bird chirps outside. Like this is that could be the case, but that wouldn't be a cause-effect relationship between them. We wouldn't look for one there because it's not psychologically compelling. It's there's something missing there about what makes it a law. So we're seeing here sort of the distinction between laws and accidental regularities. And the third thing for Hume is really it has to be experienceable, the cause and effect relationship. Because remember what he's doing is trying to ground our account of causation in terms of the existence of certain psychologically compelling and exceptionless cause and effect pairs, right? But that's supposed to be grounded in actual experience. All of our ideas have to come from experience for Hume. And so he wants to really ground it all in what we see. And so he's not going to believe that there's cause-effect relationships among electrons and photons, let's say. We don't see those, right? Those are sort of theoretical posits which are not grounded in experience. So those are going beyond what we can see in experience, at least potentially, in life. And of course, we'll move away from that when we move into a more modern reading of these things. But that's a metaphysical reading of Hume. It's important to say that there's really no causation out there in the world, and he's taking a positive stance to say that. There is, however, an epistemic reading of Hume, which is a bit more moderate. And here he's saying causation, at least insofar as we can know about it, is merely a custom or habit that we have for linking causes with effects. Right? And that parenthetical provisio is very important. Because what he's really saying is that the world may be whatever it is, but we shouldn't speculate. It's epistemically wrong to, in a way, to speculate beyond what we can know from experience. And hence, whether or not there is causation out there in the world, I'm technically open to that possibility on this reading of Hume. The epistemically responsible thing to do is to work as if there isn't. Okay, if there is secret causal magic going on out there in the world, we never see it, we never experience it, and so we shouldn't take that suspect thing and build our foundation on top of it. We should start with what we see. Maybe there are, maybe there aren't, but it's epistemically responsible to work as if there isn't. And this shouldn't hinder us too much. We can still do good metaphysical work without making these sort of unfounded speculations about what's going on in the sort of secret causal powers section of the universe. All we ever see are regularities out there in the world for cause and effect and for laws. And we can and should treat causation and laws of nature just as being efficient summaries of the world's observed patterns. We're trying to build in too much causal talk in there. We're going beyond what we're epistemically licensed to do, right? And that's, if we want our laws or causation to do a kind of metaphysical work for us that requires us to go beyond this regularities account, then we're being asked to go beyond what we're epistemically licensed to do, right? And so it's a sort of anti-skepticism, anti-speculative metaphysics reading of Hume. Here's a quote from Hume that I think exposes more the epistemic reading than the metaphysical one. Here he says, "The utmost effort of human reason is to reduce the principles productive of natural phenomena to a greater simplicity and to resolve the many particular effects into a few general causes." By causes, he means cause and effect pairs, which are constantly conjoined. And one note about how Hume thinks of laws, he sort of treats laws and causes as the same kind of thing. The laws are just the most general causes that we can identify in principle. So he really doesn't make a big distinction there. Okay, so into a few general causes or laws. Okay, by means of reasoning from analogy, experience, and observation. But as to the causes of these general causes, we should in vain attempt their discovery, nor should we ever be able to satisfy ourselves by any particular explanation of them. These ultimate springs and principles are totally shut up from human curiosity and inquiry. Elasticity, gravity, cohesion of parts, communication of motion by impulse. These are the very general causes he's talking about. These are probably the ultimate causes in principle that we shall ever discover in nature, that we may esteem ourselves sufficiently happy if, by accurate inquiry and reasoning, we can trace up all particular phenomena to or near to these general principles. So he has a skepticism that we can get beyond these sort of general causes, these observed regularities in the world, and that we should be happy with what we have and do good work with what we have, and not try and speculate too much beyond that. Okay. But one issue with Hume's approach, which I've just stressed, is that it takes our causal talk to be grounded in really direct experience and observations. He's really, if you take his anti-speculative metaphysics very seriously, you maybe end up with something like logical positivism, if you want to ground everything in observations and get rid of all sort of theoretical posits. But that's not how science works, so that's not how scientists tend to talk. We could go in a sort of logical positivist direction, but I'm assuming here we don't want to. So a scientist goes into the laboratory and they turn a certain knob and they see in a constant conjunction way, and it's psychologically compelling, some indicator needle move. And it says, when you turn this knob, there's an increased voltage. And this is basically all that scientists do. They go to their computers, type in certain things, turn certain knobs, and they see certain results on printouts or dials moving. That's all that is observed in a physics laboratory. But the scientist does more than just say that turning the knob causes the motion of that needle. There's a whole story they want to tell intermediate to this. We want to talk about electrons and electric fields and potential and kinetic energies, and we never see any of this. This is all unobservable things. Unless you bring out an electron microscope and then you observe the electrons, but still you are only observing a screen at the end of the day. Okay, so if we want to accept this sort of realistic talk about electrons and electric fields and such, then we modify this sort of Humean approach to fit with the scientific realism. And here we're going to start moving towards David Lewis. So let's drop the requirement that the cause and effect pairs must be observable, but let's keep the requirement that they're categorical or non-modal, right? Because that seems to be a big part of Hume's view as well. And this is what is picked up on by David Lewis. He has a bit of philosophy called Humean supervenience, which is named after Hume, of course. And he's got the most prominent contemporary regularity view of laws and of causation. So he says, Humean supervenience is named in the great denier of necessary connections. It's the doctrine that all there is to the world is a vast mosaic of local matters of particular fact. One little thing and then another. We have geometry, a system of external relations of spatiotemporal distances between points. At those points we have local qualities, perfectly natural intrinsic properties which need nothing bigger than a point at which to be instantiated. For short, we have an arrangement of qualities, and that is all. But there's no difference without difference in that arrangement of qualities. All else supervenes on that. So, to put a picture in your mind, this is the picture that comes to my mind when we think of a Humean mosaic. It's a painting, not a mosaic, but don't worry about it. So think about the world. Maybe say this is a time slice of the world. We're going to think about the world as a big block of these time slices. But on any given time slice, there's just a bunch of paint on the canvas. And they've got sort of geometric relationships between each other, the bits of paint. And they've got all their qualities. Here, obviously, it's just color. But you can imagine, electric field, the amount of mass at a given point, temperature, lots of different qualities you could put assigned to each of these points in space and time. But the way you're thinking about them as mosaic tiles or as bits of paint, they have no causal influence or necessary connections with each other. So if I was to take this little bit of paint here and turn it red, nothing else about the painting would have to change. I can just change any bit of paint as I want individually. Nothing's connected to anything else. Right? If these are individual tiles of the mosaic, perhaps that's a little bit clearer. But there's no necessary connections in this picture. It's just all the properties that the world has arranged in space with no necessary connections between them. And so it's a completely modally flat view of the world. And I'll tell you a bit more about what that means now. This Humean mosaic includes all of the world's non-modal properties, which means that everything is firmly grounded in the actual world. One way things are, and that's all there is. Well, Lewis thinks that all of the possible mosaics are all equally real. But let's focus in on one mosaic, and in that one world, there's just the facts of that world. And so what can go onto the mosaic? Well, you could have the shapes, sizes, motions, arrangements of parts, these sorts of things. And that would include temperature, let's say, if temperature is the average amount of motion in a given region. You can have any, and this is where we're going beyond Hume, we can have sort of unobservable quantities posted by science. You might have electric charges and masses and electric fields and things spread out on the mosaic. We don't have to directly be able to observe these things, but they should just be statements about space-time points having certain properties, or properties being located at space-time points. But importantly, there's no dispositions on the mosaic. There's no notion of stability or fragility or what would happen in different cases. Stability is, if it's interfered with, it returns to its original shape. Right? So imagine there's something which sits there in the world and is never interfered with, never disturbed. We would still want to say it's a stable configuration if we're thinking of it in a sort of modal talk where if we would go and poke it, it would return to its original state, or fragility, it would fall apart. But there's none of that on the Humean mosaic. There's just the arrangement of things. There's just the fact that it sat there and was never interfered with going on. There's no what would have happened in a different case, because none of the bits of paint are related to each other necessarily. And so there's really no causal powers that can create necessary connections. There's just the actual world with its arrangement of things. There's no direct fact anyway about what would have happened if something else had changed. Now we're going to want to give license to a sort of causal or counterfactual talk later on. But on the mosaic, there's no properties that directly license those things. We need to justify that talk in a different way. Okay? So in effect, if we're going with this Humean view, we accept Descartes' characterization of matter as passive and inert. There's no little souls in these bits of matter making them talk to each other or have necessary connections. It's a passive, inert view of the paint on the mosaic. Now let's go back to that metaphysical reading. On the metaphysical reading, which is sort of the one that David Lewis has in mind, there simply are no governing laws or causal powers to enforce the mosaic's regularities. They're just there as a brute fact. Take that to be the metaphysical situation we're dealing with. There is an epistemic reading, however, in parallel with that one I mentioned for Hume. You could say that if there are necessary connections out there in the world, if the bits of paint are secretly connected to each other somehow, we're never going to learn about it because we're only in our actual world. To know how the paint is connected to each other, we would have to go explore alternate possible worlds. We only ever see evidence from the one world. So hence we have to treat the mosaic's regularities as if they are brute facts. That's all that we're epistemically licensed to do. Now we're open about whether or not there's actual causal forces out there in the world. But we ought to work as if there aren't. Okay. Is that clear? What goes on the Humean mosaic? What's allowed there and what's not allowed there? Okay, good. Now let's see an example. Here is a bit of physics, and I hope the math's not too complicated. Don't worry, I hope it makes sense even if you don't know what these partial differential equations are. Okay, but let's go to the physicists and let's ask them what the world's like. And they'll say, we've got this scalar field. That's just a stand-in for the electromagnetic field. So it's just a simplified version of that. And we have a point-like particle, and we have some coordinate system we put out on the world to give us our geometric system of spatiotemporal distances. And then they give us a couple of equations that our fields obey. This one happens to be the Klein-Gordon equation for a scalar field with mass m, and this particle density here. And it's being sourced by the particle density. Like electric charges are the sources for the electromagnetic field. The same thing here. This term includes where the particle is at, and it acts as a source in a way for the field. And the second equation here is Newton's second law. The second derivatives of all of these coordinates for the particle trajectory is the force over the mass. Right? And it's responding to a force due to the field gradient. So the field is pushing the particle around, the particle is sourcing the field. Now, I mentioned physicists like to talk in dispositional terms. And if you take the descriptions I just gave you of these two laws, literally, they describe causal powers that exist between the field and the particle as they force and source each other. They're like responsible, the nature of the one body is responsible for how the other one moves. And they've got their own powers of inertia, and they force and source each other in this way. But we don't want any of that on the Humean mosaic. So we're given this picture by the physicists, which has all these dispositions and modal properties in it. To read a Humean mosaic off of this, we have to strip away those dispositional facts. So here's those two laws again. And ostensibly, they describe causal powers that the two things have to force and source each other. But we want to look past this causal talk to identify a sort of Humean mosaic underneath. You may need to do some work to take what the physicist tells you and find out what the Humean mosaic they're talking about is. It's not a given, is what I'm saying. Okay, but here's the key thing. This source term here and this force term here, they are just functions of the position and the field. Okay, the rho term is just like a direct delta function where the particle's at. And the force law we already gave was the gradient of the field. Okay. So we don't have to talk about sources and forces at all. Just take what these are, the formulas the physicists use for them, and plug them into the equations. And then what you get is that the laws are ultimately just a pair of differential equations, no force and source talk. They just tell us how the field and the particle sit on some fixed space-time background. There's just a regularity that these equations are obeyed. And we've sort of stripped all the modal force and source talk out by just putting them entirely in terms of the location of the particle and the value of the field at different places. Okay, so that's how we would read a mosaic off of a theory, and it takes a bit of work to do that. But now what makes these two equations I gave there, given that that's the mosaic that they describe, what makes those into laws? Here, Lewis takes a hint from Mill, who we'll talk about first. So what makes these laws is not that they're psychologically compelling regularities of experience, like Hume would say they are. Rather, they're laws because they play a sort of axiom-like role in our science. Here's a quote from Mill. According to one mode of expression, the question, what are the laws of nature, may be stated thus: one of the fewest assumptions which, being granted, the whole existing order of nature would result. Another mode of stating it would be thus: what are the fewest general propositions, so again, regularities, from which all the uniformities which exist in the universe could be deductively inferred. Okay, so what makes these laws is the deductive role they're playing in letting us make predictions and explanations. And we should go back to lecture 2 and remember that we had this distinction between entailment and governance. So on a sort of epistemic reading of what it means for the laws and the initial conditions to produce the course of events, we have the laws as a sort of sentence, a sentence maybe describing a regularity. We have some initial conditions, and these, again, deductively infer the course of events. You can do that with the laws just describing regularities. But if you want a metaphysical reading, which we're not doing here, then you need some governance to come in. So this is where we get this sort of epistemic understanding of how the laws enable predictions and explanations without going on to produce the course of events. Okay, so Lewis picks up on this from Mill and also Ramsey, and he takes the laws to be given by his best systemization. This is his best systems analysis of laws. Following Mill and Ramsey, I take a suitable system, and he means a logical system, like a first-order logic, he's thinking, to be one that has the virtues we aspire to in our own theory building, and that has them have the greatest extent, and that has them to the greatest extent possible given the way the world is. It must be entirely true, it being the systemization. It must be closed under strict implication. It must be as simple in axiomization as possible without sacrificing too much information content. And it must have as much information content as it can have without sacrificing too much simplicity. We have a balancing act of simplicity and strength. A law is any regularity that earns inclusion in the ideal system. The ideal system need not consist entirely of regularities. Particular facts may gain entry if they contribute enough to the collective simplicity and strength. For instance, certain particular facts about the Big Bang might be strong candidates. For something like the past hypothesis, the fact that the world is low entropy at the start. That's very important for us to explain things, but it's not a regularity that occurs throughout the whole universe. So he wants that to be in the system, but not a law. But only regularities of the system count as laws. So we have our best systemization of the world, which has some axioms, and then there's a way of figuring out which of those axioms or theorems of the system are going to count as laws. Some will and some won't. Right? But the laws get their law-like status because of the role they play in our theorizing. Okay, now we might have some worries about Lewis's picture here, about how he's going to justify talk of counterfactuals and causation if we're dealing with a completely flat, non-modal starting point to pull the laws of nature off of. How are they going to have any force, let's say, to help us with counterfactuals and causation? Okay, if the laws of nature just state regularities, how can they support counterfactual reasoning? According to Lewis, directly, if some bit of the mosaic were to change, if we change the paint from red to white or white to red in a certain place, nothing else changes on the mosaic. So it seems like the counterfactuals all come out strictly false. If they're saying anything changes, really. Absolutely nothing would change on the mosaic if we change some bit of it. So what's Lewis talking about when he talks about counterfactuals? And he says we continue to treat counterfactuals as we normally do. Here's one way of saying it. If we have deterministic laws and we have a counterfactual about the past, just to take a simple example, what we're invited to do is think about the way the world is now and then roll time backwards using the laws of nature, or get a good model of the past if we have access to one. And we sort of break the laws miraculously, the laws being these regularities of the world now. Right? So we just sort of manually go in and interfere and break one of the regularities that would have held in the world, just locally, making whatever change is described in the antecedent of the conditional, of the counterfactual, while leaving everything else fixed. And then we fix the laws of nature still and roll time forward, and we get to see if the consequent holds. And that will tell us, that will tell us what's going on in the counterfactual. Okay, so we hold the laws of nature fixed by fiat, just because that's how we reason. There's no real motivation to do that, because we know that if we were to just change one little bit of paint in the mosaic, nothing would change else on the mosaic. So what we're doing here is not taking the actual world, making one small change, and seeing what would result in the actual world, because that would be nothing. What we do is look for a nearby possible world which has the change we're interested in, but also has the laws of nature regularities. We look for two things in a counterfactual world to be nearby: has the same laws of nature overall, and has the small little miraculous change we're talking about. Okay? And that miraculous little change might make the laws false, technically, but we allow for that because we manually made the change. We're allowing the laws in the other world to have one little mistake. Okay. Except for the small miracle we perform in step 2. Right? So he wants us to understand counterfactuals in this way. But why should we be holding the laws of nature fixed if there's no sort of modal force that makes them be the thing to be fixed in alternate scenarios? That's a question you can continue to press Lewis on. Okay. Lewis has a whole story about causation too. We don't have time to go into all of it now, but he bases his ideas of causation on his ideas of counterfactuals. X causes Y if and only if. This is a very rough telling of it. Had X not happened, Y would not have happened. Okay. If my hand causes the pen to drop, because if I hadn't released the pen, it wouldn't have dropped. And so my hand at least has a partial causal role in it. That's just a very rough handling of it. He says a lot more about it, of course. Okay, but by invoking the laws of nature, which are again regularities spread out across the whole mosaic in our counterfactual reasoning and in our conditional reasoning, our causative reasoning, it means ultimately that there are no local facts about causation. according to Lewis. So let's consider, we have a mosaic, we have a single instance. We're looking at one little spot on the mosaic, zoomed in, can't see anything else, forget everything else. We have an A and a B, and then we have it followed by C. So does A cause B here, or does A cause C, or does B cause C, or does the conjunction cause C? What you might expect that when you look at this little patch of the mosaic, there has to be a fact about what causes what. What are the causal forces at work in that little patch of the mosaic to produce what it was? Metaphysically speaking, you might demand that this question has a local answer. Just by this little patch of the mosaic and the natures of the bodies involved, there should be a fact about what causes what. That's sort of a causal powers intuition. But we want to deny that on this Humean view. And again, we're trying to work with what we're epistemically licensed to work with and say that the metaphysical story is exhausted by, or at least all we should hope for, is what we have epistemic access to. And given an epistemic access to this little patch of the mosaic, who could tell what causes what? I have no idea. You look at a little bit of the mosaic, A and B, and then C follows. What happened? I don't know. You'd need to look at more of the mosaic to find out, right? So the idea is that we're going this epistemic route, and we're going to say that in a world with constant conjunctions of A implying C, so now we zoom out, look at the whole mosaic, and we see, oh, all over the mosaic there's A followed by C everywhere. And we go back to our little scenario and say, A is going to follow from C. So it's A that causes C here, because that's what we've seen in the wider mosaic. Without that extra context, there's no sense in which A causes C, epistemically at least, right? And same thing with B. If we had constant conjunction of B causing C all over the mosaic, or only when A and B are together it causes it, or only A and B without D, or whatever combination of things you want. But it's only once you find the constant conjunctions across the whole mosaic that you have epistemic license to say what causes what. And so Lewis wants to deny that there is a local metaphysical story to tell about causation. Because we wouldn't have any epistemic license to it if we only had that local story on the Humean mosaic. We would need to look at the whole mosaic to find it out, and that's just the way things are. Actually, there is no local causation going on. All the causation is noticing a certain kind of pattern in a global epistemic story. I don't know if that's a reasonable defense of causation or not, or if that satisfies your intuitions. That's the kind of defense that they would give. Any questions about that? How this sort of causation and counterfactual story goes for Lewis? His idea really is to get all the modal properties out of the mosaic and deal with them as a sort of way of talking about things without grounding modal properties in the mosaic. Okay, here's another worry that you might have about Lewis's best systems analysis. So the laws, and hence the counterfactuals and causations that we're describing, are not sufficiently objective. We think that there should be objective facts about what would happen if something else had changed about the past, or what causes what in any given local scenario. You might think there should be, or even given access to the whole mosaic, it might not be sufficiently objective what those are. And the reason for this is, according to Lewis, the laws are given by whichever systemization best balances simplicity and strength. We saw that in the quote from earlier. But isn't simplicity a subjective notion? I mean, what's simple for you might not be simple for me, and therefore what laws figure in the best systemization depends on you or me, and then what's causing what depends on you and me, and there are no particular notions of simplicity. This just seems entirely subjective. And Lewis does worry about this, although he ultimately thinks it's fine. He worries about what he calls rat-bag idealism. If we don't like the misfortunes that the laws of nature visit upon us, we can change the laws. In fact, we can make them always have been different by just changing the way we think. That's a concern he has. Ultimately, he thinks he can get around this and avoid the force of it anyway. He thinks that simplicity is, at least in part, objective. There could be objective notions about one thing being simpler than another. There might be vague cases where it's tough to tell. But he maybe thinks that simplicity is objective, at least when there's big differences. And that we just have to hope that nature is nice to us in a way, in that one systemization will be far and away the best, And that seems to be the case in practice, except when we get into like dualities of space-time theories and things like this. Then nature's not being so nice to us. And it seems like there's two possible systemizations of the world. And so what are the laws? There's a real contest there. In most cases, we're not so free to just change our thoughts about simplicity and change the way things are. It seems to be maybe one or only a couple ways to have a real good systemization of the world. And so if there's one systemization that's far and away the best, then none of these issues actually matter for us. We have to be a bit epistemically lucky to be in one of those worlds. Okay. Here's another way of motivating the regularity view, which actually heightens these worries about subjectivity in the laws. This comes from Helen Beebe. Imagine that we asked God to tell us every non-modal fact about the world, and he hands us his big book of facts. And it says, in the first draft anyway, at noon on Monday, the electric field at the Earth's center was 0.7 volts per meter. And there was a particle there, and it accelerated at this rate. And just lists and lists of specific individual local facts about what shape things have, what they're doing, what the field charges, what the field values are. This object A, had property F, and A was also a G. And so was B, and so was C. And just lists about what objects have which properties, and so on and so on. Right? That's God's big book of facts. That's just a sentence-by-sentence description of the Humean mosaic. Now, this is useless for limited human minds like us. And so we go back to God and say, that's a terrible book. It's really not helpful for us. Can you rewrite it to be shorter? And in the second draft, it says, okay, we've got this equation here, which tells you what the electric field was at that point, and this thing tells you how the guy was accelerating, and this thing tells you that all F's are G's. And so he erases all those specific particular facts and writes just general statements of them that cover wide swaths of them. And this is a much more human, readable book. This is much more useful to us. And on the sort of regularity account, this is all that the laws are. You take the big book of facts, you find nice regularities in it, or God does, and he erases them and writes down the statement of the regularity and thereby simplifies the picture. And that's what the laws of nature are. But doesn't this just expose another way in which the laws of nature are subjective, in a way? Because it was us who went to God to ask him to simplify the book. Even if simplicity is an objective notion, or relatively objective in the cases we're dealing with, the only reason we need the laws of nature is because of our limited cognitive capacity and the epistemic goals we have of making predictions and giving explanations, and that we can't hold all those facts in our minds at the same time. And we don't have epistemic access to them either. And so some people take this on and say that the laws of nature are, like Gorse does, the regularities of the systemization of the totality of particular matters of fact. That's the Humean mosaic picture, which is maximally predictively useful, so that's it playing an axiom-like role, for creatures like us. So it's just for creatures like us that these are the laws. We went to God and asked him to simplify things. If Martians had done it, they would have got something different. So these are the laws of nature for humans. And if different species Martians went and asked God for their summarization, he would take into account their cognitive limitations, which may be more or less than ours, and give them different laws. So that might be a worry. It might sound concerning. But one thing you should keep in mind with both this complaint and the previous one is that what's mind-dependent here is not the regularities. Those sit on the mosaic as they are. The regularities and the particular matters of fact about the world are there, fixed, objective. What's changing is based on who's asking, is their status as laws, not their status as truths. Okay? If the Martian went up and asked and got a different set of laws, the same regularities would hold in the world, right? So it's just their laws of nature which are different, not anything about the world. Okay. Along these lines, Ned Hall introduces what's called a limited oracular perfect physicist. And she has unlimited access to the first draft of God's big book of facts. She can look up any fact in there and write it down. And so it's not God who's summarizing the book, but she is. Okay, she's the sort of summarizer in this setting. But otherwise, she's just as limited as we are. She has the same epistemic goals that we do and the same cognitive limitations. She just has miraculous lookup abilities where she can go pull facts out of the book. That'd be very useful for a physicist. And if she's a perfect physicist, she would come up with some laws to describe that world with her immediate access to the mosaic. And we can still have a sort of Humean supervenience, as Lewis described, as follows. So the laws of a given world supervene on the mosaic. Once we have the mosaic, then that fixes by a best systemization what the laws are. Plus, we have to have the epistemic goals and cognitive limitations of a recognizably human, limited, oracular, perfect physicist. Once we have that law writer in mind, law formulator, and the mosaic, once you fix those two things, the laws are fixed. Right? And of course, you could change the laws by changing the mosaic. If different patterns had been there would have been different laws. Or you could change who's doing the summarizing, and that might also change your laws. But given those two things, the laws are fixed. And so considering an uninhabited world, on this view, we could only determine what laws of nature there are by stipulating the interests and cognitive limitations of some law formulator. If there was some uninhabited universe, it wouldn't have laws of nature. We could mentally project ourselves into there. If we were there and we had access to these things, we would describe it in these ways with different laws. But that world itself has no laws of nature, sans that sort of projection we make into there. But the laws might be objective nonetheless, once we've specified this. Okay, so the last thing we'll talk about is attention, a central tension, Ott calls it, which Ott has pointed out by about all of these sort of anthropomorphizations of the best systems analysis. Is the central tension. The BSA selected laws are supposed to name exceptionless regularities in the world. They're God's big book of facts. He takes all the particular facts, erases 5 of them, and writes a summary. And so they're supposed to state exceptionless regularities. And the laws are supposed to play an axiom-like role in the theories as well. They're in the best systemization because they're maximally helpful in making predictions and explanations. But at the same time, they're exceptionless regularities. What makes us think that one given set of laws can fill both roles? Those seem to be maybe aligned somewhat, but if they point in different directions, we can find situations where we can't have both. And we must ascribe our allegiance to one of them rather than the other. Here's something which Ott discusses throughout his book. Exceptionless regularities can't really interact or interfere with each other in a way that we might think causal forces can or laws can. So let's say we have a law G that describes the exceptionless regularities of gravitational motion. We have all the bodies falling under gravity. We associate the distances between them and their masses and write down Newton's laws or Einstein's laws. We have those exceptionless regularities of gravitational motion. And then in a different textbook, you find the exceptionless regularities of electromagnetic motion. Or quantum mechanics, or whatever have you. What are the laws when both theories or both aspects of the world are relevant? So again, law G describes gravity, law E describes electromagnetism. But what if both are relevant? We want the laws to be true. And so that law G that just dealt with gravitational motion needs to say, unless other forces are relevant in it. And so does law E. Has to say unless other forces are relevant. This is the description, this is the law in a gravity-only scenario. This is the law in a electromagnetic-only scenario. But other forces are always relevant, especially gravity. Right? So the laws can't be strictly true, or if they are true, they're true in a vacuous way, where if no other forces are relevant, before other forces are always relevant, therefore the antecedent of the conditional is false, and therefore the conditional is true. Right? But the important part is that this law doesn't state an exceptionless regularity. It has no instances. We make these sort of provisios about all else being the same, unless other forces come in and interfere. But these are very soft laws that don't state explicit exceptionless regularities that hold throughout the world. They, in fact, have no instances. So we might need then a combined law. We might need a law for G plus E plus ... which builds in all the possible interfering causes. This is how all the causes come to affect each other. remember we talked during the causal powers lecture about this big network of interacting and interfering causes. You need to basically write all that down into the laws. And then those laws would be true and would be exceptionless regularities, but they're no longer simple axiom-like laws if they have to build in all the exceptions and all the different things which could interfere with each other. Or at least that's what Ott's worry is, that there's this tension between being a exceptionless regularity and playing an axiom-like role in the theory. And Ott's ultimate suggestion is that we should declare our allegiance with the axiom-like part, not so much the regularity part. So laws don't have to state exceptionless regularities. What the laws do is they operate together as a sort of web of rules for making predictions and explanations. And they don't have to individually state exceptionless regularities out there in the world. They work together, and they may not have truth values individually. If you want to evaluate any one given law, you might have to look at what all the other laws and how they make predictions about the world, and as an ensemble, compare them with the world. And then when you find an issue, you have a question about which law to change or modify. It's not that, oh, we found this violation of this law, therefore we know that law individually is false. You know that the system of laws is wrong somehow, and you have options about how to change it. So you can see this as sort of a Quine-Durham web picture of the epistemological state of our theories. Okay, that's all I had to tell you guys about today. I've got some teaching evaluations, which I emailed out to you this morning, and also have paper copies here. If you guys would take these and fill them out, it'd be much appreciated. I'll give you guys some moments to do that, and then we'll take some questions.
Nice. Are you going to use this like because you said you also wanted them for feedback and like.
Yeah, I'll get the feedback later. So you don't hand these back into me; they're anonymous. I think you could hand them in paper, but if you scan them and email them to that address, they'll be anonymized and in like a couple months sent to me. Something.
Okay. Because I already had your email, so during this lecture I was like paying attention to like, what can I give you? Is it okay if I tell you also in person?
Yeah, sure.
Okay. So because I really liked the lecture, so I wanted to say that upfront. I really liked it. I think you thought it through really well, all of the content and the material. So I think the quality of the material that you're giving us is really good. And also the like very clear starting off with an overview, what are we going to do? And then like point for point, because then every time I came back here, I was like, oh yeah, like I have a reminder to the larger framework that it's great. So in general, I think for me, really enjoyed the lectures. I think they're very high quality. I just have one tip, which would keep me, but that's more in the style of presenting, which would keep me a bit more engaged. And it is the way you tend to end sentences is you go upwards towards the end.
Oh yeah.
Well, if
it's
a very specific one,
American
but it will.
habit,
but I think it will help because it keeps me more engaged if there is a sentence and it's like at the end we go down to make a point.
Yeah, to make a point. Hit the period.
Hit the period. Yeah. Wait, stop, like let it sink in, but because sometimes I was still processing the last sentence, and then you already went on, and that would feel to me more like you are telling me, literally, like giving me the story and really giving it to me, and I'm just sitting there as if I'm like watching a movie or whatever. I'm like this, literally, okay, this information is given to me instead of I am reading the information to you. Yeah. It's a different way of if that's the only thing I had, which is a very specific point, but because I think
thank you for the feedback.
That's the content really was great, and I was like, if this thing would become a bit more salient to you, I think the lectures are keep me like more engaged in a more unconscious way, where it's like, oh, okay, the way you talk draws me in. I'll write that down as well if you want.
Really appreciate that. Yeah, write it down, and I do collect these, or later these will like go into my teaching portfolio, which goes in like job applications and stuff. Yes. So do write it all down, submit it. And
Yeah.
Should we write it down in a way that you could put nice testimonials on your CV?
Yeah, I was like, I wanted to
write
just...
the truth. Write the truth.
No,
Yeah, of course, but
No, I'll make it nice because I just wanted to tell you like this specific thing because I think it will help you a lot. But I enjoyed it in general a lot.
Yeah.
So
Okay.
I'll just
I do enjoy that.
Yeah. Okay, I'll do it online because it's easier to mail. I don't know. I don't
If
know.
you can do it online, I don't. Sure. That's fine.
Thank you.
We can also do it online.
Yeah, sure. You can do it online. No worries if you wanna, if that's easier. Just wanted to give you guys a chance in case you want to do it in person. But I'd be happy to take any questions about the content. If you had any about Hume's or Lewis's view, how they work.
yeah, I think I have one issue. Or is there something about how probabilistic laws would fit
Yeah.
into that?
No, yeah. Lewis has a whole. He admits that's a issue with his original formulation of it, and he has a way to try and deal with it.
Okay.
So his paper is called Humean Supervenience Debugged. I don't have it. No, it's this one.
It's this one, yeah.
This one.
Okay.
So this one, he admits that there's questions, serious ones about probabilistic laws, and he has a way of dealing with it. And this is where he actually makes up the principle that our credences should match the objective chances predicted by our theories.
Yeah.
And a few things. So he does engage very significantly with probabilities in that part.
Okay. And the second question I had is, what about quantum mechanics or something about? I mean, at least some interpretation of quantum mechanics would maybe not say that the object or a wave function has the property like prior to say the measurement or something.
Yeah.
Then what does it mean for the mosaic?
Yeah. He also admits there's problems with this. So Lewis
That's good. He's very honest.
Quantum mechanics is always problematic.
Yeah. In this one, in Lewis Philosophical Papers, Volume 2, and I'll send you the slides so you can get the references.
Yeah.
In the introduction to this section of the book, he talks about quantum mechanics and how it's an issue for him because the world doesn't turn out to resolve into local facts here, local facts here. There's entanglement that connects them. And so Lewis admits that that's a problem for his sort of Humean mosaic view, but that has more to do with how the sort of information spread across space and not to do with the necessary connections between things. Because all you would see from entanglement and from sort of Bell violations is just interesting correlations between things. And there's no reason you have to suppose that there's any sort of modal force that causes those to happen.
In some sense, it's easier.
You can keep with the sort of Humean denial of causal powers, but you have to complicate how the non-modal stuff is arranged over space in some way, right? So that has to go, but most of the picture can... Lewis models this stuff off of classical physics pretty well.